Okay, we're getting close to the end of the unit. We're in section 11.8. Here's the I can statement. I can compute volumes of rectangular and triangular prisms. Rectangular and triangular prisms. Now the warm-up question for this is how would you describe the difference between area and volume? Now, most people are familiar with these ideas, but they can be a little bit tricky to describe. So you might want to pause and think about, well, if somebody said, hey, what's the difference between area and volume? How would you describe it? What most people come up with is this. When we're talking about area, we're talking about two dimensions. We're talking about 2D. And when we're talking about volume, we're talking about 3D. So we're talking two-dimensional space like flat things when we're talking about area. We're talking about three-dimensional things when we're talking about volume. So let's see how we can make a volume from an area. And what we're going to do is we're going to start by drawing a triangle and a rectangle, okay? Or better yet, a parallelogram in this particular case. So I'm going to start right here. And I'm going to draw a parallelogram. So if you haven't drawn one of these before, we're going to draw this so that it looks three-dimensional. So we're going to draw a rectangular prism. But the weird thing is we're going to start by drawing a parallelogram. So make it look something like that. And then here's what we're going to do. That is a two-dimensional area right there. And to make it 3 dimensions, we're going to kind of make it jump off the page. So here's what we're going to do. I'm going to draw a line straight up about that far, and I'm going to come over here and I'm going to draw one parallel to it straight up about that far. So I'm going to make them both so that they're about the same height. Now I'm going to come to the front corner and I'm going to draw one that's about that same height right there, not all the way up to here because that would be too far. So I'm going to do it about like that. That looks pretty good right there. And then I'm going to do the same thing right here. So it's almost like, kind of like we're building a building or something like that. So we've got the floor right here, and then we put these corners in, and then we're going to go through and we're going to connect the corners. Now, if it didn't turn out perfectly, like I think that one's a little bit too tall, that's okay. It's going to look just fine. That's what it looks like. Now, you'll notice I've got this little kind of swooping line right there. I can fix that, make that look just a little better. And you'll notice that this parallelogram that represents the top is basically the same shape as the one that represents the bottom. Now, one thing that we could do to make this look a little bit better, make it look a little bit more three-dimensional, because some people will look at this and they'll think, oh, it's kind of going into the paper, and other people will think it's kind of jumping off the paper, is we can do this. I'm going to erase that line and I'm going to make it dotted. Okay? And I'm going to do the same thing one at a time with these guys so that I want this to look like it's going kind of back into the page. So that's what it looks like right there. Okay, now this a lot of times we'd call this the length. Okay, and this is what we call a rectangular base prism. So we call this a rectangular prism. So let's say that this is 5 for the length, and I'm going to put an L there. Okay, so I'll put equals that. And this is 4, and we're going to call that the width. And then this is going to be the height. I'm going to say that that's 6, and I'm going to represent that with an H. Okay, so I've got the length, the width, and the height. Okay, so in order to figure out what the volume is here, because we're taking up a three-dimensional space right here, even though we've represented it on this two-dimensional piece of paper, is we figure out how many squares fit on the bottom. So basically we do this. Okay, so we're going to go 1, 2, 3, 4. So there's 5 meters or whatever it happens to be over there. Okay, and then we're going to go kind of split it in half. So we figure out how many squares fit on the bottom. So if you wanted to go through and count these, there are 5 going this way and 4 going this way. So that would be 20 squares that fit on the bottom. And then what we're going to do is we're going to figure out and see how high we can stack cubes in there. So we fill the bottom with squares and then we stack cubes going upwards. So I'm going to change colors here and I'm going to draw a line right here like that. And this gets a little bit sticky. So basically what I'm going to do here is I'm going to go through and say, all right, I've got all of these little cubes right in here. So there's one right there. There's another one right there. Okay, so I see how many I can stack up. Well, the way we figure this out is we say, look, if there were 20 squares on the bottom and we can stack this, take a good look here, we could stack this 6 units high. we'd do 20 times 6 and we'd end up with 120 whatever units they were. So we'll talk about the units in just a second, but that's the basic idea. Now if we do this with a triangular base to make what we call a triangular prism, and that's why we've got a rectangular prism here, and then we're going to do a triangular prism right here. So this is what we're going to do. We're going to start by drawing a triangle. So I'm going to draw a triangle like that. So go ahead and draw one on your paper. And then we're going to do the same thing. We're going to put some corners on this. So we're going to go straight up, and straight up. All about the same distance here. Okay? Then again, we're going to connect these. Now I'm going to make that a little taller so that it looks right. Okay? Connect those. Now again, for some people you'd look at this and you'd think, oh, that's a tent, and then for other people you'd look at this and kind of say that it's a triangle kind of pointing off, jumping off the page and stuff like that. We can clean this up and we can make it so that everybody's seeing the same thing by doing this. I'm going to erase that line and make it dotted. I'm going to erase that line and make it dotted, and then erase this line and make it dotted. So what we've got here is we've got this rectangular front right here, and then we've got a rectangular side over here and a rectangular side over here. And the important part is that the bottom is a triangle. Okay, we call that a triangular base. And I want you to notice the vocabulary here. We called that a rectangular base, and this is a triangular base. And notice that that's a big capital B on each one of those. That's going to come up here in just a second. Okay, so the way we would figure this out is we would figure out, well, how many squares can I stack on the bottom? So we're going to do, I'm going to have the base times the height. So we would find the area of that base, 1/2 base times height. Let me make that look right. Okay, so we'd figure that out, and then we'd figure out how tall we could stack those. So we'd do the same thing. Once we figured out how many we could put on the bottom, like this, we'd figure out how tall we can stack it. And that looks a little bit funny, but that's the basic idea. We figure out how many we can fill up the bottom with. Okay, let me shade this right here. And then we figure out, like how tall can we stack them. Same type of idea there. So what we do is we'd have to figure out, well, gosh, this is where it gets a little bit interesting. That's a height right there, and that's a height. So we've got to be a little bit careful. So I'm going to put a question mark here, and we're going to talk about how we can deal with that type of notation. And this isn't an uncommon thing in math. We'll often run into a place where we've got variables that kind of conflict, and I'll show you how we deal with those. So volume is the three-dimensional space that an object takes up. And rectangular prisms have, no surprise here, a rectangle for a base, and triangular prisms have triangles for a base. Now prism is just a fancy word for it. So if I said I've got a prism right here and a prism right here, they're both just boxes. So a prism is just a fancy word for a box. Okay, so this is how we figured out how to compute the volume, especially for this one here. That one's relatively easy. But in order to understand the formulas that I'm going to write down, we need a vocabulary word, and that vocabulary word is base. Big capital B on the front of that. Okay, so the big capital B means the area of the shape that forms the base. So in general, the formula for a prism is just this. It's just going to be a big capital B times H. So I'm going to write this down. The formula for a rectangular prism is big capital B times H, and the formula for a triangular prism is big capital B times H. The difference between the two of these is how do we compute that area that makes up the base. So how do we compute this area right here, and how do we compute this area right here? Okay, that rectangle down here and that triangle over here. Well, this is where I want to point out something else, and this is called a cross section. Okay, so let me get rid of these guys right here, that right there. So you'll know that you've chosen the correct side or the correct face of the three-dimensional figure as the base of the prism if you can slice the prism parallel to the base and get the same cross-sectional shape. So I'm going to clean each one of these up just a little bit so that it looks a little bit better. Okay, so it looks like that. Get rid of these guys right here. Kind of clean up the inside of this. Okay. So here's what we're talking about. When we're talking about a cross section, we're talking about kind of like taking a knife or a sword or a chainsaw or something like that, and I'm going to change to a different color. Okay, so I'm going to write the word cross-sectional. Whoops, cross sectional. Okay, we're going to get the same cross-sectional shape. So what I mean is, if we take this and we slice it parallel, we're going to get a slice that looks like this. So if we were to slice it horizontally right across here, we're going to get that same shape as what the base is. And if I do another shape or another slice, I get that same cross section. Well, if I come over here and I were to slice this horizontally, here's what I get. I get a shape that's like that. And if I were to slice it right here, I get a shape that's like that. So because that's exactly the same triangular cross section all the way up and down, we know that we've selected the right side for the base, meaning big capital B right here. Okay, so we know that this is a triangular prism because it's got triangular slices all the way up, and we know that this is a rectangular prism because it's got rectangular slices all the way up. So all you have to do is remember this formula, and then you need to know, okay, if it's triangle, I'm going to use 1/2 the base times the height to find the area, and if it's a rectangular prism, I'm going to find that by just doing the length times the width or the base times the height. Now I do want to take just a quick second. Some of you may have learned it this way. For a rectangular prism, it's the length times the width times the height. And again, there's no problem with that at all. Perfectly okay to do that. So I'm going to come down here and we're going to run through and we're going to do a bunch of these. Okay, let's take a look at this one right here. We're going to find the volume. This happens to be a rectangular prism, and notice that it says round to the nearest hundredth if necessary. We'll see if that becomes a problem down the road. Now, most people like to have this bottom part be the base, so we're going to think of it right here. That's going to be the base. So I'm going to write this: volume equals big B times H. So we're going to find the area of the base. So the volume is, the area of that would be just length times width, base times height, if you want to think of it that way. 10 times 4, and then multiply it by the height of 2. So this is going to be 10 times 4 is 40, times 2 is 80. Now we've got to think about units. I told you earlier we talk about units. Remember, this is going to be 10 feet times 4 feet, 4 feet, and then times 2 feet. So what we have here is feet times feet times feet. So feet times feet is feet squared, and then of course if we multiply it by one more, it's going to be cubed. So when we're talking about volume, we always measure those in cubic units, so keep that in mind here. Now on this problem, this happens to be a triangular prism. A lot of people like I said before, they like the base to be on the bottom. So what I'm going to do is I'm going to transfer each one of these measurements down here. So this is that back side right there, and then this is 4 right here, and then they did us a huge favor. That is a right angle. I'll make it look a little bit more like a right angle. And then again, what we're trying to find is we've got to find the area of the base so that we can find the volume. So the volume formula is the area of the base times the height. That area in the base happens to be a rectangle, so it's 1/2 of the base. So I'm going to do a 4 times a 3. Remember, these two are the ones that are perpendicular to each other, so we leave that 5 out of there. That would be slanted if we looked at it that way. So we're going to have the area of the base is 1/2 of 4 times 3, and then we need to know how tall it is. Well, we transfer this over here, so that's going to be a 7. Now think about this for just a second. We're going to have half of 4, so that's going to be a 2 times 3 times a 7. 2 times 3 is 6, times 7 is 42, so the volume here is 42, and this is centimeters, and again we're multiplying a centimeter times a centimeter times a centimeter, so this is going to be centimeters cubed. Okay, so there's our answer on that one. I'm going to do this one in kind of a quick way because, again, if this is the bottom right here, we can do that, but we basically end up with length times width times height. So we're going to do 9 times 6. Oh, I apologize. 9 times 11, because those are the two sides right there. 9 times 11, and then 6 would be how tall we can stack it. Not that it would matter because we're multiplying those together the same each time. So this is going to be 99, and then times that by 6. We end up with 594. Again, we're going to have cubic units here, and since these are yards, this is going to be yards cubed. Okay. I do want to show you this really quickly. Notice how that cross section is the same as the base, and this cross section is the same as the base. Let me erase a couple of these guys right here. This cross section is the same as what we used, same as what we used for the base there. And then notice that this is a triangular prism, but it's kind of laying on its side. So if I were to draw a cross section that matches up there, I'd need to draw it something like that. So what I want to do is I want to find the volume by doing the area of the base times the height. The area is going to be this triangular area right there. So this is going to be 1/2 of that triangle. So that triangle is 8 times 6. And then we times it by how tall we could stack them. How far do we have to go back, if you want to think of it that way? That's going to be a 10. So we're going to cancel. That's a 4. So this is 24 times 10. So this ends up being 240. And then the units on this particular one are meters. So this is going to be meters cubed. Whoops, let me make that look right. Meters cubed, 240 meters cubed. Now, this last problem on here, it doesn't say actually find the volume. It just says how would you find it. So take a look here. This might not be as bad as you think. This is what we call, now take a look here, 1, 2, 3, 4, 5 sides. So this is called a pentagonal prism. Okay, pentagonal prism. And the cool thing about this is, even though you may not have been taught how to find the volume of something like this, notice this big capital B right there. The general formula for a volume of a prism is big B times H. In other words, how many squares can you stack along this pentagon? And then again, notice this cross-sectional slice right here. Okay, that looks kind of crappy. They're all that same shape going back there. So we just need to know the area of that pentagon and then know how tall you can stack them. Well, the area of the pentagon is 43 millimeters squared. Notice they've got the units right there. And then we'd multiply that by 15 millimeters. So we'd get millimeters cubed. Now, if you want to throw that in your calculator, you're welcome to do that. I think you end up with 645. Yep, I think that's right. But that's how you do that. So the power of this little formula can't really be underestimated because it's so good when we've got prisms. Now, thought question here. What do we get if we slice a prism perpendicular to its base? So perpendicular to its base. So I'm going to come up to this one right here. I'm going to erase these guys. And we're going to take a look at this again. Okay, actually I'm going to leave the 3, the 4, and the 5. Now, if this is the base, if this is the bottom, if we did it perpendicular, so if I were to take a sword or a chainsaw or something and slice it right here, here's what I'd get. I'd make a slice like that, but it would go back and like this. Could do the same thing right down the middle here. So let's say we sliced it like that. Do you know what shape we would get for each one of these? Well, on that one it would be a rectangle. Okay, if we did the same thing here, on that one it would be a rectangle. And if we did it right here, that one would also be a rectangle. Okay, and if we drew one on here, rectangle on that one also. Okay, so if we sliced it perpendicular on each one of these, we're going to get a rectangle. Okay, now depending on the prism, whether it's a right prism, meaning it comes straight out of the ground or something like that, you may get something different, but on all of these we happen to end up on a rectangle. Now that's not terribly important, but it is something to kind of keep in mind and just kind of work out those skills of being able to draw different shapes and figures and stuff like that. So good luck with the assignment.